Good evening, everybody, and welcome to Pacific Science Center's Virtual Science in the City Talk. My name is Zita Strickland, and I will be your host tonight.
Good evening,
I want to thank all of you for joining.
Pacific Science Center's Virtual Science
I am in
City
an
Talk.
echo right now.
My name is Zita Strickland, and I will be your host.
And I am free from echo. There are some strange things afoot sometimes in our technical and digital world. And today we're going to be exploring those with the haunting of Pacific Science Center, Science in the City. But before we get started, there's a few things to share with you. So before we start tonight, I want to let you know that all of our past Science in the City talks can be found on our YouTube page. You can explore pizza making robots. You can look at Mars landing and the different rovers that we've sent to the Red Planet. You can learn about the science behind Climate Pledge Arena currently being built right in the Seattle Center. Or you can learn about the art of skepticism and how to call BS. All of those are on our YouTube page, and there's some great things that we remain curious about and to learn. In addition to these past talks on our web pages at PacSci.org, you can learn about a lot of other programs that we have and we're offering. We have virtual field trips for school groups. We have short curiosity breaks for corporate groups. And we even have activities that you can download and do at home by yourself or with your learners. Now, all of these activities would not be possible without the generous support of our donors. And so we would like to take a moment to thank everybody who has made a donation to help make these events possible, including the Science in the City that you are seeing tonight. If you're able, we also like to suggest a $15 donation for tonight's talk. This helps us ensure that curiosity never closes. For more information, you can go to curiosity or PacSci.org/support. Now, for tonight's talk, we have some amazing things that are happening. And there's something spooky that's stirring at PacSci. There's mysterious phenomena that are happening all over the place, all over the museum, and they need to be investigated. Human senses can be pretty easily fooled, so we're going to have to examine what we see pretty carefully. And as you're being curious and examining closely, and while this is a virtual event, it's still an interactive event. And there's a couple of key ways that we'll be interacting. First off, on your YouTube feed in the comments section, if you have a YouTube account, you can type a question or a comment right into that comment feed. Some people were talking earlier about where they were watching from. That's the way to ask a question of our speaker. And after the main part of tonight's presentation, we'll be asking those questions of her and finding the answers. But you don't have to wait until the end for that interaction, because there's going to be some interactive moments during the talk as well. And now's a chance to practice that interactivity. Occasionally, you're going to see a QR code like this. All you need is a smartphone, maybe a web phone, a cell phone, a tablet with a camera function. Go ahead and give this a try right now. Turn on your camera and then point it right at the screen, right like you're going to take a picture of that. You should see a little pop-up for a Google form that appears and takes you to 3 easy questions. Take a moment now, open up that form, give us some answers to those questions. Again, this is a little bit of a practice for later, because 2 or 3 different times in tonight's presentation, you're going to see something just like this. All right, let's take a look at who we have. We have some people watching by themselves. We have some people watching with their pets. I want to give a shout out to Karen, to Mochi, I think, Inara. Ooh, good pet name right there. Yeti. I am going to imagine Yeti as a big, fluffy dog. Somebody's watching with Callie, one of my favorite pet names, I have to say. Severus. Ooh, wonder what kind of a pet that is. Awesome. Oh, I love we have so many pets watching. I wonder if they're going to be having a spooky time of tonight as well. Awesome. Keep those smartphones handy, because you are going to be needing those throughout tonight's talk. All right. Now, We've practiced that. I think we are ready to interact with our guest speaker tonight. Dr. Kaitlyn Casimo is tonight's ghostly speaker. She is the training and outreach specialist at the Allen Institute right here in Seattle. She's received her PhD in neuroscience from the University of Washington. And when she's not doing science, she likes to play tennis, knits, and also volunteers at Pacific Science Center as one of our science communication fellows and is on the advisory council at Seattle Rep. This is her 5th Halloween with Pacific Science Center. And Kaitlyn, I'm so excited that you're back tonight for another haunting of Halloween in the Science Center. Welcome.
Thank you. I'm happy to be here to help investigate these spooky sightings that have been popping up at the museum.
Yeah, I'm glad that you're here for this. So we don't have a lot of people at Pacific Science Center anymore, and we don't have any guests. So it's very strange right now. I'm in once every week or two, and it's a little bit different. It's a lot quieter, but also a lot of the lights are off in various areas. So especially when I walk through the dinosaur area and there's all these big dinosaurs and they're just sort of looming over me and it's kind of dark and they're not moving. That's the one where sometimes I'm sort of a little looking over my shoulder.
Well, we're gonna go check out those dinosaurs and some other reported hauntings. So let's head on over.
That sounds great.
All right, can you see my slides?
I sure can.
Great. Well, thank you everyone for being here. I'm happy to be with you in spirit tonight. The puns aren't gonna get better from here. The museum has been closed, but as we said, the staff have been reporting some mysterious sightings. So what we're doing tonight is that we're charged with investigating and resolving these reports. Is it a ghost or is it just an illusion? So what kind of ghostly phenomena have been reported? People on site have been seeing, hearing, and feeling things out of the ordinary that they're worried might be ghosts. But there's lots of reasons that that could be happening, so we need to critically investigate this before we jump to the conclusion that it's a ghost. In particular, it's well known that human senses can be tricked, misled, or misinterpreted by our brains. And an illusion occurs when your brain misinterprets the information coming in from your senses, your vision, your hearing, your touch, all of your senses, to create a perception of something that doesn't reflect reality. Your senses are working just fine when this happens, but what you're sensing is misleading or ambiguous in a way that your brain struggles with. Everyone knows about optical illusions, but illusions can affect all of your senses: touch, hearing, and even senses like time and temperature that we're less consciously aware of. So there's many different ghosts from around the world with different ranges of power. And we've seen a whole host of hauntings involving people sensing things, but nothing actually being moved around. Like we know Casper can move things around, or Peeves the poltergeist. And we're definitely not seeing any time travel or big hallucinations like we see in A Christmas Carol. There's no one's out for vengeance in the museum like Banquo, this ghost from Shakespeare in this middle painting, and also from this time last year. And of course, there's many types of ghosts from around the world, like these Japanese ghosts. And this just seems to be a pretty benign ghost, if it is a ghost at all, just some weird sensations that people are feeling around the museum. So here's our first opportunity to vote tonight. Use your camera app on your phone to scan this QR code. You should be able to just point it at the screen, open your camera app, and it'll offer you a link to go to a form where you can tell me what are your favorite ghosts. And I think Zed is also gonna post it in the chat. So I'm gonna hang tight here for a moment, let you go ahead and scan that code. And you can tell me what your favorite ghosts are. And we're gonna come back and review the results of that at the end of our investigation. Great. So go ahead and finish scanning. If you need to keep voting while I move on, great. But we're gonna return to that later. So we're gonna get into our ghostly investigation now. We're starting our investigation with a report from near the IMAX theater. A staff member reported seeing shapes appear in this railing above the ramp down to the theater lobby. And she said it looked like shapes were being formed in these railings. Was it an optical illusion or a ghost? So let's see what she reported. Did you see that movement over there in the bottom right corner of this image? Let's replay it and see if we can catch it again. All right, I've highlighted this to show the motion more clearly, but it does ruin the ghost effect a little bit. There you go, you see that motion in the railing. Now let's see that original haunting as reported again, without the visual enhancement. So we can get a really good look at the shapes there created when those lines pass through that railing. So it looks like it could have just been a staff member walking down the ramp, carrying a fence above their head, passing behind the rail. So it probably wasn't a ghost. But what were those lines and why does it form shapes like that? So this illusion is an instance of what are called moire lines. This is an illusion that occurs when gratings like this pass across each other, temporarily forming new shapes and distorting depth, and in particular, edges. Now, edges are points or lines where there's a change in brightness. In this case, a very strong change from black to white. Your brain breaks down those visual inputs that you see that come in from your eyes into various components and processes, which happen somewhat separately. And among the very first thing your visual system does when processing a scene is to detect those edges. In this case, the images are made up almost entirely of edges. And this pattern is called a grating. Some of this early processing also includes simple movement. So this fence carrier really tricked your vision right at a basic level into thinking that there was a ghost floating behind the railing. So let's look into the steps of visual processing in a little more detail. So while it feels like your brain processes what you see coming in from your eyes as a whole, the various parts of an image are actually processed somewhat independently and then pieced back together to make what you feel like you see. Visual processing is what it's called, how your brain takes the information that comes in from your eyes and turns it into the image that you are consciously aware of. Some of the most basic features that your brain processes are edges and simple movement, which also includes the preferred angle that these edges are sitting at. So the ones that I'm showing here are up and down, but some cells prefer edges that are sitting at, say, a 37-degree angle. And some cells prefer a still line versus a moving line. And every cell in your eye and brain has an area of your visual field, that's what you can see, that it's responsive to. In the eye, and in those very early stages of visual processing in your brain, that area of your visual field, the area you can see that those cells are responsive to, is pretty small. But there's also cells that respond to much larger areas. And all of this processing also combines information from both of your eyes, which gives you depth perception using differences in angle between your eyes for the area that you can see with both eyes. And for area that you can't see with both eyes, that area you don't have really good depth perception in because you need that offset in the angle. But I'm not really going to go into that because ghosts don't have depth, other than to say that this also helps with the figure ground problem, which is distinguishing an object from its background. This example of a figure ground problem here is itself an illusion that's either two faces on a white background or a vase on a black background. Shape, color, and movement are all also processed separately and somewhat individually. And only very late in the process does an object get identified as a ball just thrown at your face or something unidentifiable like a ghost. So let's get oriented in the brain. The front of your head is on the left side of this diagram and the back of your head is on the right side. So you're looking at the left half of your brain, looking from the side. All of what I'm about to describe is also true for the right side of the brain. That's just not what you can see in this image. So all of these steps of processing that I mentioned mostly occur in the occipital cortex, which is located at the back of your head. This whole region of the brain, which is home to an estimated 140 million neurons or brain cells just in V1, the main visual processing area alone, is in charge of visual processing. But other areas are involved too, especially with the difficult job of identifying whether what you just saw was a ghost. So what happens here is that information travels from your eyes via the underside of your brain. It then travels to the thalamus, which you can't see in this picture, but it's located pretty much in the dead center of your brain, all the way to the occipital areas at the very back of the brain, which is on the right side of the slide. And then as that information gets processed, it moves back towards the front of your brain. And all of this processing starts in V1, where that edge detection, simple motion, and some color gets processed. And also V2, which combines signals from your two eyes, which again helps with depth perception. Then the information gets split and actually gets processed separately in these two streams called the where and the what stream. And they are surprisingly independent of each other sometimes. Just now, we all jumped at the movement in the fence without knowing what it was. And who hasn't instinctively caught something that was thrown at you before identifying it? So let's start with the where stream. That's the dorsal pathway. And it takes that basic information and runs it through V5, also called MT, and V6, also called DM, medial temporal and dorsal medial areas. These two areas really drill into motion detection, putting objects into context and tracking them. They also help control your eye movements to keep a moving object in view, like a thrown ball, and eventually to direct your body to respond. V6 especially helps account for the movement of your own body relative to an object. These areas have to work really fast in order to keep up. The location and movement information then gets passed to the motor areas, pointed out here with arrows, so that your body can respond, sometimes before you've even consciously processed that image. The ventral stream also takes that basic information and runs it through V4, which pulls out more of these colors and patterns and sends it on to the inferior temporal cortex. The what stream also accounts for what you're paying attention to. It responds more strongly to things that you're already tracking. Among the jobs of the temporal cortex is memory. And in this case, what that means is taking that visual image that you've finally processed and rooting around in the archives of your brain to figure out what it is, or at least to try to put it into some context. Like I said, this works much more slowly than the where pathway, but it's better to jump out of the ghost way now and figure out what it is later. But anyway, that railing, not a ghost, but your where pathway got you jumping out of the way in time to be safe. So specifically with regard to color in processing, your brain can be really weird about processing color. It looks like these two spots on the breezeway are the same color in context, but if we zoom in, they aren't. Your brain corrected the color for you based on the context of knowing that this whole breezeway should be white as a ghost. So let's take a look at the whole breezeway again. And then there's those two spots. You can see that they are not the same color. So this is the classic version of that illusion. It's the reverse of the breezeway, where it looked like two surfaces are the same color because the context tells you that it's all white. This time, it looks like squares A and B are different colors. The reverse box is on the checkerboard and one is in a shadow. But the actual color, like in pixels and not in the context of the image, is the same. Your brain auto-corrected the colors for you to account for the context of the shadow, or in the breezeway, the ghost. Or maybe it was just years of footprints. There it is with the context again, and without the context. The dress is also an example of this phenomenon of your brain accounting for the context of color. The lighting in this photo is really bad in such a way that the context is ambiguous. It's actually black and blue, but some people's brain interpret the lighting context quite strongly and overcorrect for it. So you see white and gold. So go ahead and use your camera app again, scan this code, or look for the link in the chat, and you can vote on which colors you see. And I'll show the results at the end. This really divided people on the internet a few years ago. So while you're voting, remember that I said that the areas that process color include V1 and V4. What's happening here in your brain is that you are processing both the actual color of the pixels on the screen and also putting it into context through that what pathway, up to and including not just identifying what colors you see, but also identifying it as a dress. It's at this contextual phase of processing color that you see differences between individuals. I'll give you a few more seconds to go ahead and scan that code and get your vote in. Tell me whether you see black or blue or white and gold. I see black and blue. Great. So when you adjust the color balance of that photo, it can help your brain interpret that color context differently. The center image here is the original meme. Adjusting the white balance of the image can make almost anyone see it as black and blue, which is the version on the right side, or push the balance more towards white and gold. But even in that leftmost image, I still see black, I don't see gold, but I do see white instead of blue. This may also depend on your screen settings of the device that you're watching us on tonight, so you might also end up seeing it differently on different devices. Anyway, on to the next spooky sighting. So that wasn't ghosts, but we were getting some reports of spooky phenomena that weren't visual. Our next report comes from the main permanent exhibit hall. What about this weird sound that a staff member recorded coming from the tide pools? Let's play that. It sounds like someone is slowly sinking into the tide pool forever. All right, let's go check it out. I'm going to play that sound for you again, and we're going to look at the spectrogram of the sound and figure out what it is. A spectrogram shows you what frequencies of sound are appearing in a complex sound. And I, based on the spectrogram, recognize this as a Shepard-Risset glissando, also called an auditory barber pole illusion. It's sort of the sound equivalent of a constantly spinning barber pole that the ribbons always look like they're going down. It sounds like the tone is continuously falling forever, even though the number of tones available will, of course, run out eventually. So how does it do it? Most sounds are a combination of many frequencies. So as you're looking at this spectrogram here, the y-axis on the left side is the frequency of the sound. Lower frequencies towards the bottom of the graph are deeper sounds, and higher frequencies towards the top of the graph are higher sounds. And the color tells you how much of that frequency is present in the sound. The x-axis is just time. And I'm going to play that ghostly sound again, and I want you to look at this visualization while I do. This visual shows you about the first 5 seconds of the sound, but it just keeps repeating in that same pattern. So I'm going to play that for you. See that the illusion comes from this conveyor belt of new tones that are being added to the chorus of frequencies in this sound that then slowly fall and then get replaced by more high tones entering. It sounds like it's continuously falling, but it's not. It's new tones that come in, continuously fall till they get to the bottom of this frequency range and then get replaced. And that's why it's called a barber pole, because it gets this falling effect. You may even be able to hear these little pops in the sound. That's what's showing up in the spectrogram as these bars that cut through all frequencies. Give you another couple seconds to listen to that. So this brings up the question of how your ears and your brain process those sounds and why that conveyor belt of frequencies is so deceptive. A sound is made up of a combination of frequencies of sound, and each frequency produces a different note on the scale and every note in between. Inside of your inner ear, so that's what we're looking at here, the cochlea, that's the purple part on this diagram, forms a spiral. And inside of that spiral, there's a long membrane that's sensitive to different frequencies of a sound. When you hear the sound, it pulls on the membrane and it activates the brain cells in that part of the spiral. And that signal then gets sent to your brain. So those are actual like brain cells that are inside of your ear, neurons. The combination of frequencies that reach the brain gets processed and it makes the sound that you hear. So think back to the spectrogram. You were hearing both high and low tones at any point in the sound, which activate different points along the cochlea. While a falling sound with only one tone in it would eventually hit the bottom of your range of hearing. For most people, the cochlea is sensitive to sounds ranging from about 20,000 hertz at the high end to about 20 hertz on the low end. Our speaking voices are in the range of about 400 to 500 or 450. that we keep reintroducing those higher tones, and your brain integrates those individual frequencies into a complex sound. If you don't have perfect pitch, and very, very few people have perfect pitch, you're not consciously processing the exact frequency or pitch of those notes, just how they relate to each other and combine. Most people don't even notice the new high pitches being introduced into that shepherd risset glissando, so you don't notice the illusion's effect. It just feels so natural. So that ghostly sound is probably just a tide pool pump or something else making noise, keeping those starfish healthy. So our third ghostly report is from the dinosaur room. Somebody reported that they felt the ghost of a dinosaur, an uneasy feeling of someone standing behind them, and a dinosaur-sized shape out of the corner of their eye. Maybe those ghostly dinosaurs have come to warn us of their experience with climate change. I've gotten a recording with a really nice microphone that can capture a wide range of frequencies. Let's take a listen to that. Well, you probably can't hear much because this is very low in the human range of hearing. But I took a look at it earlier with my trusty spectrogram, and I can tell you that there is sound happening there. So let's play it pitched up. So you should be hearing this hum. Let me play it pitched up one more time. There we go. There's the sound. So you remember I said that humans can hear sounds down to about 20 hertz? A sound below 20 hertz is below the range of human hearing. This is called infrasound, and it includes all sound waves that are in that very low frequency range. Well, you can't hear the original sound with your ears. You can feel infrasound in your body. And unless you know what's happening, or it's especially loud and you can figure out that you're feeling these vibrations, you may not even be aware of it. Because you don't often experience such deep sounds and they're not coming in via your ears, the normal way you experience sounds, they can induce some really creepy feelings, like that you're being watched or that a supernatural presence is there. One group of researchers ruined people's night at the opera to test this when they played an infrasound tone about 18 hertz under the orchestra that was playing. Almost a quarter of the audience reported feeling unsettled, afraid, chills, or a supernatural presence. The researchers had noted that they were in a modern concert hall, and if they'd had the same experience in an old castle, or say with some dinosaurs breathing down their necks, the audience might have attributed that vague and unexplainable feeling of a presence differently. So that explains why we have this dinosauric presence. But what about seeing a dinosaur ghost? So it turns out that sounds at exactly 18.5 hertz, that's 18.5 vibrations per second, not only produce that effect, but that's also the resonant frequency of the human eye. This causes the eye's shape to become distorted in time with the sound. So you remember I spoke about visual processing earlier, and I focused on the steps that happen in the brain, but it all starts with those light-sensitive rods and cones that are actually in your eyes. The 18.5 hertz wave starts activating those cells by pulling on them when the eye distorts, rather than having light hit them. But this effect isn't very precise, so it just causes this indistinct blobby shape and not anything specific, but that sounds like the ghost of the dinosaur. Well, not the ghost of the dinosaur, just the whirring of their mechanics causing infrasound effects. Our last reported haunting is that a staff member working in the makerspace by the machines over by the window reported suddenly feeling a strange combination of hot on her left hand and cold on her right hand. And then suddenly the sensation swapping when she walked away from that haunted spot. It's a little harder to collaboratively investigate a touch illusion over video call, so I went and checked this one out myself. There's lots of fun equipment that visitors can use in that Tinker Tank makerspace to create their own things, and some of them get hot, like a jigsaw. Plus it's cold outside right now, so the windows can get cold. So what happened here is that our staff member's left hand got warm and her right hand got cold while she was working on a warm machine by a cold window. And then when she turned around, both of her hands were back in that neutral room temperature. Her previously hot left hand now was comparatively cold, and vice versa. Well, it seems like temperature is part of experiencing what you touch. It's actually its own dedicated sense. It has its own cells, not just in your hands, but all throughout your body that respond to increasing heat or cold. My hands and feet are always cold, but those sensors are everywhere. These cells aren't like a thermometer. They don't register a precise temperature. It's sort of like how you don't consciously recognize a specific frequency. But you know what feels pleasantly warm, and you know what feels frigidly cold. But what matters moment to moment is relative temperature. Are you getting warmer or are you getting colder? And your hands, in this instance, our staff members' hands, happen to experience an opposite relative temperature change at the same time. The hand that previously was hot moved into that neutral space and felt colder. The hand that was previously cold from the window moved into the neutral space and felt hot. And you can try this at home. Set up 3 bowls of water, tap hot, not boiling, iced, and room temperature. Put one hand in the hot water and one hand in the ice water and wait 30 seconds, and then put both hands into that neutral water. The hand that was in the hot water will feel cold, and the hand that was in the cold water will feel hot because of that relative temperature change. And you can fool your temperature sense in another way, with dinner. Menthol, the main flavor in mint, actually activates the same cold receptors as something chilly. And capsaicin, the chemical that makes spicy food spicy, activates heat receptors. So when you say something is spicy hot, you are actually experiencing the same physical response as something actually hot. So in conclusion, there's no ghosts here, but many thanks to the staff of the Science Center for being on their toes and ready to report anything out of the ordinary that they see. My spooky point is that you can't always listen to your senses. You have to trust your common sense to overcome illusions and determine what's really happening. As a reminder, illusions are caused when your brain is doing its best to interpret something ambiguous or misleading, and when you happen to hit a loophole in your senses that they're just not equipped for. Your eyes and your ears and your temperature sense and all of your other senses are doing their best, collecting input from the world around you. But as with any information, that input can be misinterpreted. And it's not only your vision that can be fooled with optical illusions. This goes for all of your senses. We covered a few of them, but also others like proprioception, the sense of your body's position in space, temperature, pain, time, smell and taste, and more. And you have to think critically about what you think you're experiencing, not just for the things that you see, hear, and feel around you every day, but for everything you read and hear, or someone might be trying to convince you of with a photoshopped image. Critical thinking is more important than ever. And I want to thank Diana Johns for supplying all of the ghostly images throughout the talk. Please go ahead and take a moment to vote for which ghosts you spotted through the talk. There were no actual ghosts at the Science Museum, but I may have planted a few in some of these images. We'll go back and take a look at the results in just a moment. And I do want to mention, none of these reported hauntings really happened. The Science Center is safe, friendly, and ghost-free, and looking forward to welcoming you back soon.
Awesome, Kaitlyn. Thank you so much. I'm excited to see these results.
Yeah, I'm pulling them up right now. I see a bunch of votes have come in. All right. So I think more votes are coming in on for which ghost did people spot. So we'll give that one a moment. So let's start with favorite ghosts. All right, here are your favorite ghosts. I am seeing no one's favorite ghost is just the ghost from A Christmas Carol. Or if it didn't count your votes correctly. I promise your real votes will get counted more accurately than these votes. The ghost from A Christmas Carol, but only the Muppet Christmas Carol version. We got about 11 votes for that. We've got almost 20 for Casper. It looks like any of the ghosts from Harry Potter and Beetlejuice are our leaders with about 24 votes each. We have about 17 for ghosts from Folk Tales and Mythology of the World. about 13 for Banquo and or Hamlet Senior, about 15 for Pac-Man, second place for Ghostbusters, about 22, and then about 7 for Among Us, the trendy ghosts. And then let's see what we had for the dress. All right, looks like we've got a good number of votes for that. I'm seeing 29 people see it as black and blue. I'm seeing 41 see it as white and gold. 6 are seeing it as potentially both ways. And about 8 people see it some other way. All right, I'm gonna quick update the votes on our third poll, because I think more results have come in from that. Yeah, we've gotten a few more votes there. So it looks like most people spotted the ghost on Science on a Sphere and floating down the ramp to the IMAX theater. I don't think anybody spotted the breezeway trash can. And it looks like a few more people also saw it in the Tinker Tank rafters and in my virtual background, and a few in the palm tree, and not very many spotted it washing its hands at the tide pool, which is funny because we should all be washing our hands right now.
Thank you so much, Kaitlyn. That was great. I know that when the sound one came up, several people on YouTube were commenting that their dogs woke up and were looking around.
Oh no, I'm sorry, puppies.
I think it was before maybe even we could hear it, because you had 3 different. Yeah, I couldn't hear it until the third one.
Well, that's why I pitched it up, to make sure that everyone could hear it. Different devices have different ranges of what frequencies they can produce. I know that my computer really struggles with low frequencies, and that the higher pitch sounds are more into that average range of everyday sounds that we interact with. So then you should be able to hear that at least.
Mm-hmm. So I think now we're going to go ahead and start looking at our comment section and taking some questions from there. So any questions that you have, go ahead and put it right in the comment section on the YouTube chat, and then we will ask them of Kaitlyn and test our senses a little bit more. So our first question that we're going to take a look at, actually it's a really interesting one. It's a question from Joy asking, has anyone ever died in the Pacific Science Center? Kaitlyn, I don't think we expect you to know the answer to this one. I will say that, so I've been at Pacific Science Center for quite a while, about 20 years. And to the best of my knowledge, there was a death of natural causes, but it was well before my time. When you think about the Science Center, it's been open since 1962, initially opening with the World's Fair. Some years we have close to 1 million visitors come through our doors for a year. That's been almost 60 years now. But to the best of my knowledge, it has only happened once. And again, natural causes and quite a while ago. So let's take a look and see, are there other questions that are coming in? Alexandra has a great comment. I'm thinking about just past exhibits. We had, many years ago, I think about 15 years ago, we had the exhibit from Titanic come through. And this exhibit was amazing, and it had some constructed set pieces to look like parts of the Titanic ship, but it also had a lot of artifacts that actually were brought up from the ocean floor. And Alexandria notes that when that exhibit was there, she felt something near the big piece. There was a big piece of the hull, and it felt like something was looking out of the hull at people. So that's an interesting feel to have done.
A lot of times when you experience these sort of presence or an unexplainable sort of something is there, it can be something like infrasound that your brain just doesn't really know how to interpret that.
Mm-hmm. Diana's wondering, do you think dogs can hear or see ghosts?
Well, I think, so dogs can hear better than we can. Dogs can also certainly smell better than we can. So as anybody who has interacted with a dog or a cat as well will know that dogs and cats can sense things that before their humans can. whether you believe in ghosts or not, then yeah, I guess you could say that a dog could detect things that a human can't. Like I said, there's no ghosts here, so no dogs would be detecting those. But yeah, animals' ranges of what they can sense are different, and for some senses in some animals, wider than what humans can detect. My favorite example of that is the rainbow shrimp, which we have we have 3 types of cones, which are the light sensitive cells in your eye. These rainbow shrimp have 15. So their sense of color is much more precise than ours. And also the range of light that they can detect is much wider than a human. So they can see well into the range of what we would call ultraviolet and infrared, which is beyond what a human can see. We can feel infrared light, that's heat. And we can eventually feel the effects of ultraviolet light, that would be a sunburn, but we can't see them with our eyes, and those shrimp can.
Mm-hmm. Yeah, when thinking about pets, it always gets me when you're in a room with a cat and they just stop suddenly and just look over your shoulder at the wall and there's nothing there and they stare so intently. Yeah, that's always a good one. So Liz is thinking about sound again and wondering if there are sounds above the range of human hearing, can those also make us feel funny?
Yes, but not in the same way as infrasound. So a really good example of what happens when you get a sound that's really right at the level of what you can hear is that it's just this really annoying whine. I'm actually not sure what happens when it's beyond what you can hear at the high range. I think you just can't really detect that. But when it's right at the level of the high end of your hearing, it forms, it's this like really pervasive, like you can't ignore it hum. And it's actually been used as like a deterrent to prevent people from congregating places. There's been some instances of like shopping malls using it to try to prevent teenagers from congregating, because teens generally, as you get older, you lose the high end of your hearing range. So children and teenagers can hear at a higher maximum frequency than an adult. So the idea is that the teens can hear it and it will be annoying and they won't hang out there. And like maybe you just have some teenagers hanging out. They're fine. Teenagers are cool.
Okay, well, here's a quick one from Levon, and also a special shout out to Lakeland. Hi, Lakeland. Lakeland is 5 and watching. And their question is, Ghostbusters or Casper?
For me?
Yeah.
It has been a very long time since I've seen Casper. I'm going to go with the new Ghostbusters, actually.
Oh, I've never seen it. I think I'm going to go old school Ghostbusters.
Old school Ghostbusters is too. Casper, I think, might edge out if I had seen it in the last 10 years.
Yeah, I don't think I've ever seen it, but now I know that I need to. Okay, back to a more serious question. Karen's asking about auditory messaging. So sometimes like she will somewhat reluctantly hear a short phrase that was something from her deceased dad. It's not scary, but she's wondering if it can be explained scientifically.
So when you hear a sound, much like when you see something that you haven't identified what it is, when you hear a sound that it's not clear what it is, sometimes your brain will ascribe or assign a meaning to it. And that may end up being something meaningful, like the voice of a loved one. And sometimes when you hear a sound that's ambiguous, you can just interpret it in 2 wildly different ways. So there was the one with the dictionary, reading out the word of Yanny versus Laurel, and it was supposed to be Laurel, but some people heard Yanny. And that's your brain trying to ascribe meaning to that ambiguous stimulus. So that could be one reason that you hear some sound and your brain is trying to assign meaning to it. Our brains don't like it when we have things in our environment that we don't know what they are.
Yeah, that meaning makes a lot of sense. So what happens to our brains then in that trying to ascribe meaning and just process the world when we're tired? Why does it seem to be so much easier to be scared or tricked when we're tired? Does it have to do maybe with some of the signals that are being processed? That's a question from Scott. And Scott, that is a great question. I've definitely noticed the same thing. When I'm tired, I feel like my guard is down. I have a pretty good startle reflex. And definitely if I'm tired, I think that comes out a bit more.
Yeah. when you're tired, it can impair the speed that you process things, and also the complexity. It takes a little bit longer to sort of put together those complex thoughts and interpret stimuli. That's why, for example, they say that driving tired can be just as bad as driving drunk, because you're responding slower, you're not as able to put together information from your environment, from the context, and you're specifically slower to make decisions. So those of you who came last year know that decision making is a complex process, and it requires the function of multiple different brain regions working together. So when you're tired, your brain is sort of taking shortcuts sometimes to just keep going and until you can go to bed. And that can, in addition to the more obvious things like responding more slowly, having impaired decision making, it can also make it so that it's harder to process those ambiguous stimuli.
So that's happening when you're tired. What about when you're stressed? So Diana's curious, have there been more reports that you know of ghosts or supernatural experiences this year during this time of COVID-19 when stress is just on a very different level?
I have no idea. Part of it is context. So when you experience a phenomenon that it's not immediately placeable what it is, what your brain sort of decides that to assign to that stimulus that you're experiencing depends a lot on the context. So if, like with the orchestra example, that those people were in a modern concert hall and that they were just sort of like, I felt a spooky presence. But if they were in a castle, they might say, oh, that was a ghost. But fewer people are going places. So I don't know. I have no idea.
Yeah, that context is really interesting. I've definitely spent more time. I know my own home a lot better. So I think maybe a sound that previously I would be like, what is that? Now after being home all day, I'm like, oh, I know what that sound is. That's an interesting one. So Danielle has a question, which is a great one. Sorry, it's a question actually from Abby. Why does it sometimes feel like someone's watching you when you're in an entirely empty room or space?
Well, there's a variety of reasons that you could feel that. For example, the infrasound could be one cause, though most of us aren't experiencing infrasound in our homes. Like if you experience infrasound, it's going to be at a place like an airport or a construction site or near a highway that you're going to get these really low frequencies, which are going to be generated by very large objects. Actually, whales also generate infrasound. Yeah, if you happen to be in the ocean, I guess. But there are other things like static electricity. If you get an electrical buildup in the air, which can especially happen as we head into winter and the air gets drier, which also makes virus droplets travel better. So everybody, please be safe. Wear your mask. That can cause the hairs like on your arm and on your body to stand up, which gives you a sense of somebody standing behind you. Or we're all stuck at home, so maybe somebody really is standing behind you because there's only so much space in the house.
That could be. Probably not the empty room phenomenon on that one.
No,
unless
but
they sneak out before you realize they're there.
Yeah.
Can you remind us again the dress?
Yes. Let me show the dress again.
Yeah, and it'd be great. John Terry is asking, could you review again, why do some people see the gold and others see the blue? That one always gets me as well.
All right, I'm bringing up the dress. Here it comes. All right, so I'm showing you can see this, right?
Yep.
Great. So I'm showing the version of the dress that has the multiple different white balances. So the version in the middle is a black and blue dress in a badly lit dressing room. So what is happening here, actually, let me go back and show the single version. So what is happening here is that your brain is looking at this and it is trying to determine how much of that black and blue color is coming from the dress itself, the object in the image, and how much of that color is coming from the lighting. So how it is, everybody's experienced something that is you buy this sweater online and when you actually take it out in the sunlight, it looks like a totally different color, inevitably uglier. So for some people, their brains correctly attribute some of that lightening, that white balance, to the bad lighting in the photo. Again, the dress really is black and blue in real life. Other people's brains interpret the lighting as being, or the color you see on the screen as coming not primarily from the lighting, but is coming primarily from the object that is being lit. So whether you see black and blue or white and gold is depending on whether your brain is interpreting that ambiguity as coming primarily from the lighting versus primarily from the object. So let me show you the color balance version again. So again, the center one is the original. The one on the left, they've turned up the white balance. So this is basically washing out the image. And it makes it easier to attribute more of the context to the lighting. So it means for more people that they're gonna see it as white and gold rather than black and blue. Whereas on the version on the right, the white balance is turned down. So it shows the less of the context of the lighting. It makes more of the color appear to be coming from the dress itself. I hope that answers your question.
I think it does. But if anybody wants to hear that again, just a reminder that this talk will be saved on our YouTube page. So you can totally take a look and listen to that again. I kind of feel like I want to listen to that again, but block out the different dresses so I can just see one dress at a time. Because I'm totally on the white and gold camp and have a really hard time seeing the other.
Black and blue. I can't see it as white and gold.
I can't see it as black and blue. Together, we're an amazing visual team.
Look at us. Look at this experiment.
I love it. Karen's wondering, can you speak a little bit to how alcohol affects sensory processing?
Yeah, alcohol does not precisely affect sensory processing. It affects your whole brain. So sensory processing among them. And one of the main things that alcohol does is that it makes all of your sensory processing much slower. So that's again why you should not ever drive drunk, because you're not going to be able to respond quickly. And when you're going 60 miles an hour, you have to respond fast. Mm-hmm. So that's the main effect of alcohol. There's also a ton of research on the ways that alcohol affects specific areas of the brain. I am not super well versed in that, but it does absolutely affect the way that you perceive the world, because it also affects your decision making. It affects the speed of processing. It affects especially your executive function, which is executive function is basically all of the organizing and personality and the things that you think of as being you. And it affects that particularly strongly. And then that is taking in information from your senses and using it. So it affects how you think on multiple ways, top to bottom, all the way through, including every sense and how you use them.
Yeah, and since the brain is processing all those senses together to paint that picture of the world, and give us that understanding, it's impacted on different levels. Kaitlyn, do you believe in ghosts that can't be explained scientifically, or do you think it can all be explained scientifically?
I don't believe in ghosts. I think that it can all be explained scientifically, but I'm also not going to tell anyone what to believe. If you believe in ghosts, you should continue to believe what you want to believe.
Excellent. Thank you so much for sharing all of this with us. Some really interesting phenomenon, some amazing things that I think are definitely going to be continue to be thinking about. Do you have a favorite fictional ghost?
Ooh, that's a tough question. There's a lot of good fictional ghosts out there. A lot of which made it into the poll. I think from the poll, my favorites are Banquo and Hamlet Sr., which is anybody who came to Halloween 2019 last year will know the reason why. I am a giant Shakespeare nerd when I'm not doing science. And I think also the ghosts from A Muppet Christmas Carol are among my favorites off that list.
Yeah, Muppet Christmas Carol might be some of my favorite ghosts as well, for sure.
Also, I guess I can kind of count The Good Place as ghosts, kind of.
Oh, I think we can count those.
Okay, then I'm going to count The Good Place.
I think those totally count. Final question, just a parting question. Are there any other sensory illusion sources that we can train our brain to see through? And are there any, if we wanted to continue this exploration of sensory tricks and how our brain processes, what direction would you send us in?
Yeah, there is an online database of illusions. So if you search for illusion database, it'll come right up in Google. There's also an annual illusions video competition. I don't remember the name off the top of my head, but it's an annual contest put on by, I think, one of the psychological societies, like a research group, that gets people to make little videos demonstrating illusions. So there's always some really good ones in there. It's not just cool videos that demonstrate known illusions of different senses. Like, people actually create brand new illusions, and then they explain the psychology and the neuroscience of why they work. So it's a really fantastic resource. I can find that, and if we can like add it to the YouTube description, I'm happy to do that.
Yeah, I think we can definitely add it. And if you find it quickly, we might even actually add it into an email that we can send to everybody who has signed up to watch.
Yeah. And then, I briefly touched on this, but there's also not just illusions, but also misleading images. There are lots of different ways that you can detect whether an image has been manipulated, not just whether is it tricky and ambiguous, but whether it has been deliberately altered, and not in the clumsy way of me adding that fence carrier, but in a much more subtle way. There's a lot of different tricks of how you can spot that sort of thing. Things like shadows being out of place or reflections being wrong. They're not really illusions per se, but they are tricking your brain in the same way. And I'm actually going to show an example of that because I can.
I love it. Bonus illusion.
One more illusion. Whoops. All right, one more illusion here. This is called the Thatcher effect, and this is a great example of an image that has been manipulated. So this looks like two identical upside down faces of Margaret Thatcher, right? But your brain really likes looking at faces. So it's actually fixed this face for you. If I flip them right side up, you'll see they are not identical. The one on the right has had its mouth and eyes flipped so that the upside down image has a right side up eyes and mouth. But your brain just auto-corrects that for you. On the scale of evolutionary time, your brain has no reason to encounter a face with the eyes and the mouth flipped upside down. So it just fixes it. You have a whole brain area that's called the fusiform gyrus that just loves looking at faces, processing expressions, identifying people, and it just goes ahead and fixes it for you, makes that face look right. So that is a great example.
Love it. Fantastic example. Thank you so much. Kaitlyn, thank you so much for joining us tonight and explaining some of the hauntings that we have seen at the Science Center. Thank you for your friend joining us as well. And thank you to everybody who watched and joined us tonight. We would love to hear your feedback of tonight's event. So please take a couple of moments and fill out a short survey. We're going to put it in the link right here on the YouTube chat, and we'll also email it to everybody who registered in advance. Your feedback is super important as we figure out new programs to bring to you. Also, remember to sign up for our new e-newsletter at pacsci.org/science in the city and to donate at pacsci.org/support. If you enjoyed tonight's talk, or if you just need to watch that dress illusion again to understand what it is, this talk will be saved on our YouTube page, and you can watch it, you can share it with friends, and you can really dig in and learn more and see if you can train your brain to see through these illusions. Before we go tonight, Kaitlyn, I want to thank you again for joining us tonight. Yeah. I want to thank all of you for watching along with your pets. Special shout out. We had a couple of Thors, Sir Oliver, Koompa Troompa the chicken, and thank you for watching Bread and Cheese. Have a great night, everybody, and happy Halloween.